I'm going to talk about finding probabilities for a standard normal distribution with a computational device. So in the previous video, we talked about standard normal distributions. Those are normal distributions with a mean of 0 and a standard deviation of 1. And here's an example. Suppose that the temperature of freeze pops are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1 degree Celsius. What is the probability the temperature of a randomly selected freeze pop is less than negative 1.78 degrees Celsius? So we said that that probability is equal to the area under the curve. So the probability that z is less than negative 1.78 is equal to this area under the curve of the standard normal distribution from negative infinity up to negative 1.78. And that is equal to the integral again, from negative infinity to negative 1.78 of that value. However, basically no one actually does this as an integral because it's actually a difficult integral to do. Most people either use a table of values or a program or a calculator or an online computational tool. So in this video, we're going to use an online computational tool to do this. To find these probabilities. Here is one such computational tool, and that's the one I'm going to sort of showcase in this video, but they're all fairly similar. If you just search for or Google normal distribution calculator online, you'll find a lot of similar sites, and this first one, this StatTrek one, is probably one of the first ones that will come up for you. This is what it looks like. So, when you go online, it will look like this. There will be these 4 boxes, and most of the time we are going to be entering into this box whatever value we're interested in. In our case above, like negative 1.78 would be what we would plug in. And for us, right now, we are talking about a standard normal distribution, and like we said, a standard normal has a mean of 0 and a standard deviation of 1, but these two things are changeable. So later when we're talking about the mean different normal distributions, say like height of adult men or a set of IQ scores or lengths of rabbits or whatever, normal distributions with different means and different standard deviations, we can use the same approach. We just have to plug in the mean and plug in the standard deviation. So once those 3 things are plugged in, you just hit the calculate button and it will give you an answer here. So here is that plugged in. Again, I plugged in these 3 items, and then after we hit calculate, the program gave us this, gave us 0.038. And so what that is saying is that the probability that z is less than negative 1.78 is 0.038. So 0.038 is that probability right here. 0.038, the probability under the curve of the standard normal distribution below negative 1.78. Or, in our contrived example, the probability that a freeze pop is below negative 1.78 degrees Celsius. All of our examples for the standard normal distribution are a little bit contrived, but once we're talking about any normal distribution, any mean, any standard deviation, we'll be able to use more realistic examples. So many computational devices like this one tend to give the probability that z is less than a particular value. So they always give the probability that z is less than something, whatever we plug in. And if you use a table to find standard normal scores, probabilities, it will do the same thing. We're always looking at the probability that a data value is less than whatever we plug in. And so we can use that, though, to find questions like what is the probability that the data value is more than a number or between 2 numbers. So let's look at finding instead the probability that a freeze pop has a temperature greater than negative 1.78 degrees Celsius. So then we're looking at the probability. If here is negative 1.78, we're looking for the probability that our temperature is up here. So think for a moment, what is the relationship between this area in purple and the area above in red? Well, we know that for any probability distribution, the total area under the curve is always equal to 1. So because the total area under the curve is always equal to 1, that means this area in red, the probability that z is less than negative 1.78, plus the area in purple, the probability that z is greater than negative 1.78, is going to be equal to 1. Again, remember that for continuous distributions, the or equal to part doesn't matter. We could put it there or whatever, but the total probability of both of those things together will be equal to 1. And so that means that if we wanted to solve for this one, we could just get it by itself. That means that the probability that z is greater than negative 1.78 is equal to 1 minus the probability that z is less than negative 1.78. And so we've calculated that. So 1 minus what we've already calculated, we found that the probability that z is less than negative 1.78 is 0.038. And we did that again with our online computational device. And so we just need to subtract. And so the probability that z is greater than negative 1.78 is equal to 1 minus 0.038 is equal to 0.962. So this probability right here is 0.962. And generally speaking, anytime we're looking for the probability that z is greater than a particular value, we'll do 1 minus the probability that z is less than that value. All right, let's look at another example. Suppose that scores on a personality test are normally distributed with a mean of 0 and a standard deviation of 1. Again, a standard normal distribution. If an individual is randomly selected, what is their probability that their score is between 0.53 and 0.24? So now I'm looking for the probability that the score is between 0.53. So here's our 0.53 and 2.4, so about here is 2.4. So we're looking for the probability that our data value, that the score on this personality test, falls within this range. This is the probability that 0.53 is less than z, which is less than 2.4. So if we're able to always find the probability that a value is less than a particular number, how could we find the probability that we are between two values? So we can find the probability that, we're less than this value. We can find the probability that we're less than this value. If we can calculate those two probabilities, how could we find the probability that we are between the two values? So think about that for just a moment. Okay, so if we plug in 2.4 into this distribution, then that would be, so this right here in green is the probability that z is less than 2.4. And then we could also plug in 0.53, and we could find the probability that z is less than 0.53. So that's all of that in red back there. This is the probability that z is less than 0.53. And again, each of those things are easy for us to calculate. If we get those two things, and we can do that above, so here I plugged in 0.53, here I plugged in 2.4, and for this I got a probability of 0.702. So 0.702 is that probability in red, and 0.992 is that probability in green, so 0.992. So if what I really want is the probability that's currently shaded in black, how would I find that? Well, I could take the area shaded in green and subtract away the area shaded in red. So that is the probability that 0.53 is less than z, which is less than 2.4, is equal to the probability that z is less than 2.4 minus the probability that z is less than 0.53. So that is 0.702 minus, that is, the large one is 0.992 minus 0.702. And so when we subtract, we'll get 0.290. So 0.290 is the area shaded in black. That's the probability that we're interested in. And anytime we want the probability that a data value is between two values in the normal distribution, we find the larger probability and subtract the smaller probability. Okay, so here are a few for you to try out. If a set of data comes from a standard normal distribution, what is the probability that a randomly selected data value is greater than negative 1.57, less than negative 1.57, and between negative 1.57 and 2.4? So find each of those probabilities. Again, you can use a computational device or a website like the one that is listed above to find these probabilities. But I'd also like you to sketch the relevant probabilities on a standard normal distribution. So as we were sort of sketching the areas that corresponded to these probabilities above, try that on your own drawings of standard normal distributions as well. Okay, the probability that a data value is greater than negative 1.57, so negative 1.57, something around here, and we're looking for the probability that we're in this shaded region that the data value is greater than negative 1.57. Since a table or most of these computational devices always give the probability that a data value is less than something, that means that we need to subtract whatever we get from 1. So the probability that z is greater than negative 1.57 is equal to 1 minus the probability that z is less than negative 1.57, or less than or equal to, again, doesn't matter, and that's equal to 1 minus. Now we can use a computational device, and so when we plug in negative 1.57, this will be the output, and our output is 0.058, and so when we subtract that from 1, we get 0.942. So 0.942 is this probability. And one thing that's useful in doing these sketches is that if you had, sort of forgotten a step and thought that this was the solution, and then you look over at our drawing and see that, okay, the probability I want is this large shaded area. It's larger than a half because it's more than half of the area under the curve, so it's larger than 0.5, for example. It should be much larger. So this can't possibly be right, but this is okay. Less than negative 1.57. So for less than negative 1.57, that is this shaded area, and less than is what the table already gives. So we've actually calculated this already. The probability that z is less than negative 1.57 is equal to 0.058. And between negative 1.57 and 2.4, so then we are looking at negative 1.57 up to 2.4, and we're looking at the area under the curve between those two values. So what we need to do is find each probability and then subtract them. So we already found above that the probability that z is less than 2.4 was 0.992, and we also found that the probability that z was less than negative 1.57 just now, we found that that was 0.058. And so the probability that we're just in that black shaded region, we want to take everything below 2.4, that is this probability, and subtract away the part that we don't want. The part that we don't want is this probability, so we don't want this piece. And so the probability that negative 1.57 is less than z, which is less than 2.4, is equal to 0.992 minus 0.058. And so we just need to subtract. And subtracting gives us 0.934. So the probability that we're between those two values is 0.934.